Okay? And it's forms. Okay, any cubic polynomial is of one of two forms. It could be ln times ln times ln, meaning what?
Linear times linear times linear.
Yeah, meaning like x minus 5 times x minus 3 times x plus the 14th root of 87. Okay? And you might have something like that, okay? It probably wouldn't be a 14th root, but still. So, it could be three linear factors. And you can actually determine, if it's of this form, what the linear factors are, because there's an algorithm for solving cubic equations. I learned it for a while when I was in like 10th grade. Remembered it for a year or so, but never used it again. And I could, now I know enough mathematics, I could reconstruct it. But no point, okay? Unless you're another theorist, and even then, I'm not sure. Because it's kind of well, anyhow, it doesn't matter, okay? So you got this form, or the form linear times an irreducible quadratic, because it's got to be linear times quadratic. Either that quadratic is reducible, meaning you can write it as a product of linear, meaning that it has two zeros, or it doesn't have any zeros, in which case it's irreducible. Okay? So this would be a quadratic with no zeros. And it's going to have a graph of, well, let's not even draw a y-axis, because we can't confine this to a quadrant. So it's either going to have a graph like this or a graph like this, right? Okay, if the quadratic is like this, or like this, where this is the x-axis, or even like this, or like this, touching the x-axis only in one point, okay? It's going to be like this. If it touches the axis in one point, two of the linears are going to be the same, because the quadratic is going to be a perfect square, okay, of linear factors. So there's that much to it, and it's not that hard to sort out, at least if we don't go beyond cubic polynomials for right now.